Recording again and start the class. So I'm going to leave this up, but if you look at the Python files that are in here, there's one called turtledata.py, and that's the one we're going to base our lab off of. There's also this one called read CSV example. I think I'm gonna put that off because we're actually gonna talk about pandas. A couple more lectures. We're gonna switch over to raster data next week and talk about that for 2 weeks. So we did vector for 2 weeks. We'll talk about raster for 2 weeks, and then we'll look at the pandas data package when we start doing some charting and that sort of thing. So even though this is examples in here, I'm not going to go over that one today. But it's interesting. It basically shows you how to read a CSV in a comma separated values file. But we'll look at that a bit later. So this is the one that I'm going to open up. I'm going to right click on it and say edit with IDLE and pull it up. It's really simple the way it is. There's not much in here. Similar to the one where we put in a city and we got a location. This is a URL. In fact, I can copy this URL right here. I can copy it and paste it into a browser window. And if I give it a number between 1 and 244, I'll just do 11 here. What it does is it returns a turtle track. So these guys at conserveturtles.org have put little, you can see the pictures of them. They've put little GPS receivers on a bunch of turtles. See the little GPS receiver there? And they put GPS receivers on them, and then it's not every single day. It's like 3 times a week. They ping the turtle's location from the GPS receiver, and they get a latitude and a longitude, and then there's a distance. I don't know what exactly that distance is in terms of. It's supposed to represent distance away from the last one. But I don't know what units it's in. We could figure that out ourselves later. What we're really concerned with is the latitude and the longitude. So this is turtle 11. Now this is turtle 25. That's turtle 255. That's out of the range. Sorry, I thought I only pressed. That's turtle 24. This is turtle 50, and so on. So you see that there's a bunch of records for every single turtle. Okay, there's 255 different turtles. So if I run this, what it's doing is it's fetching that URL, and if you look at the data that it's returning, it is in this format called JSON. But JSON is really similar to Python syntax. So in Python, what is let me make that bigger. What is that bracket? What is it returning? It's returning a list. Exactly. And then what is inside of the list? What's this mean? Right. It's a dictionary. And so where does this dictionary end? I think it's right there. So that's where the dictionary ends. So this is a list of dictionaries. And every dictionary has a latitude, a date, and a distance, a duration, and so on. Okay. It has all that information. So what I'm getting here is this uh, this this library JSON loads f, in other words, the contents of the URL that I opened. It loads it into a variable that I call turtle data, and turtle data is simply a list that contains a bunch of dictionaries. So if I run this the way it is, I'm going to get the turtle data for turtle 244. See how it says turtle 244? So that's turtle 244, and this is just the information for that turtle. So how would I get the first location in this list? Right. Well, I do think these are sorted. Let's look at the data here. So it looks like it's starting July 31st, August 1st, August 2nd, all the way down. It looks like it's going through the next year. Finally, we're at October 22nd, 2014. So this one ends in 2014. Some of them go all the way up till present day, and some of them go to 2017. So at some point, I guess the battery runs out or something. The turtle dies and sinks to the bottom, or a shark like rips off the top part. I don't know, but yeah, something happens. Yeah, maybe if the location just stays constant on shore or something, they figure the turtle died. Ow. Anyway, they take it off. So the very first location is the first track. So how would I get that? In other words, how would I get this location? It's a list. How do I represent that? First of all, what variable is that information in? What's the name of that variable? Well, there's really only one. Yeah, it's in turtle data. See, turtle data is the variable that loads turtle data loads all of this in, right? Every single last value. Okay. So if I want just the first one, how do I get it? Remember, it's a list. Turtle data bracket 0. Exactly. So now I'm going to get, instead of getting all the turtles information, I just get its very first beginning location. And by the way, it actually says that's the starting one. Like that's under icon it says starting. It says start. Now all the other ones just say current. I don't think they have an ending location. Like I think every single one of them they assume is current. Is the last one. I'm not positive. Let's see. So this was what, 24? Let's see what the last one says. Why doesn't that? There we go. The last one says last known icon current. Title, last known location. So, anyway, sorry, what are you asking the question? Okay, I think that you're confusing some things. So I'm giving this turtle ID 244. So this is actually the most they only have 244 turtles in their database. So this is the first location of turtle 244. Yeah. So if I want to get the very first turtle in their database, I would say 1, and then this would give me the last The first. Oh, I'd have to print it. Right, so now I'm getting the first location of turtle 1. See, that's turtle 1, and that's turtle 244, and that's the location, the very beginning for turtle 1, and this is the very beginning for turtle 244. So, what's that? Can you speak up a little bit? Yep. Yeah, so they just tagged turtle 244 is what that's saying. See what I'm saying? So if I go get all the data for turtle 244 on October 18th, that was the start. It was at this latitude and longitude, and then on October 19th it was here. On October 20th it was here. On October 21st, which was yesterday, it was at this location. See what I'm saying? So it's swimming around out there. Now what we want to do is we want to write a script that'll go through and it'll make a record, a row, for every single turtle out there. So we need to loop through every turtle, and then we need to build a line that represents where that turtle went, and then we need to store that in a shapefile so that we have, or a geodatabase, I don't really care, but we need to have a layer called turtle tracks, and it has 244 entries, and it has a line that represents everywhere that turtle went. And we're going to assume it just traveled in a straight line between the points. I mean, in reality, it probably didn't, right? In reality, it probably went a few different places. Wouldn't you think? Right. But every few days we have a point, and we'll just connect all the dots using the points. So we kind of get a rough idea of where that turtle went over the period of its tracking. Does that make sense? So we're going to have just a big spaghetti mash, right? When we finish, we'll have a big line of all the turtle locations. But we could look at the turtles one at a time and see where they went, or we can also see, like, you know, kind of like where turtles go in general, right? We could do all sorts of stuff with the data, but what we're trying to do is to get a line that represents all the places the turtles went. So in reality, this isn't actually much different from this last example 6, right? Where we just did something like this. In fact, let's take this code and adapt it for that particular code, because right now, everything, you know, after right here, we could just copy and paste over there, and we would be able to, sorry, what'd you say?
Is that example loaded up onto GitHub?
No, let me do that. So I'm just going to go File, Save, make sure it's not any different. I should have done this earlier.
Are those like tornado tracks stuff right too? Is that tornado tracks or?
Kind of. I mean, they're like tornado tracks in that they have, you know, multiple points made up that make up a tornado track. For some reason, it makes me log out here. Hold on a second. I need to options. Sometimes it makes me sign out and sign back in before I update. There we go. I think it's working now. Yep. Okay, so now that's up there. Let me make sure. Week 7. Yep. Example 6 is up there. Okay. We need to do a few things. So right now I'm just going to copy all this stuff over. All the stuff after Hattiesburg, right? And copy this down here. Okay. So we're going to need to do a few things. One thing is we're going to need to change this back to polyline. And we're going to need to change this back to polyline. And just for fun, let's call this turtle tracks. Thank you. Turtle tracks. Okay.
And you copy the turtle code above the example 6 code. Right.
Well, I copied it into the turtle data code. And I'm actually going to save this as Raber George 1 or sorry 7.1.py because that's what it is now. It's the answer to the test question. I mean the answer to the question. So our goal, what we want to do is we want to have a shapefile that has all the turtle tracks from 1 to 244. Now, actually, I noticed that for whatever reason, there are 5 or 6 turtle tracks that are empty. So I think what that means is that, you know, they put a homing beacon on some turtle and they released it and they never heard from it again. So maybe the beacon was faulty or whatever, but there are some that come back empty. That, in other words, they look like, I don't know, I don't have any of them memorized, but we'll encounter some. Let's see what 200. I mean, I'm not gonna. There's only a few of them, so I'm not gonna get them just by guessing. Well, 0. They kind of look like this, though, actually. So I just put in 0. Turtle ID 0. You see how it's just an empty bracket. See the bracket? There's nothing there. In other words, there's no track. So how should we handle that? I think we should just skip them. If there's nothing there, skip them. But there is something from 1 to 244. Okay, and 244 is the newest turtle. We can tell it's the newest turtle because it's got some points. But 245, there's actually a list of the turtles on their website. So I knew 244 was the last one, but 244 is the last one. Okay. All right. Okay, so let's modify our code. Right now, for turtle 1, right now we're getting turtle 1. So turtle data is a list. We've got a list down here somewhere that we're creating that we're creating a list down here that we're feeding in. So this is these are the lines of code that we need to adjust to make it so that we're going to get the turtle data. Should do that on here. These are the lines of code that we need to adjust so that we're feeding the turtle data in rather than the get address location. So in other words, we need to change this right here to something else. Okay. All right. I think we could do it all with that. Yep. We could do it all with that. If we wanted to make this a little more simple, we could do it like this, actually. X equals, oh, well, actually, this wouldn't work. We also need to change this. Instead of for city in cities, we could just say for something, I'm just going to say something in something else. All right, then y equals, all right. All right, so yes, turtle data is going to go in there somewhere. You got any good suggestions, Elvis, as to where turtle data might go in there?
Well, since you say create turtle data, again, is the location of the turtle. So there is a location, so turtle data, one is the division. Turtle data 0.
We actually need to go through all of the turtle data. We need to create a loop that's going to go from, because remember, turtle data 0 represents the first location. Turtle data 1 represents the second location. Turtle data 2 represents the third location. Turtle data 3 represents the fourth location, and so on. See what I'm saying?
Right.
Right. So how do we make a loop that goes through each element in the turtle data?
You gotta put like something plus 1 so it keeps going.
Yeah, I mean, we could definitely do what you're. So Ashley's saying instead of doing a for statement, we could do a while statement or something like this. While x. Yeah, so we have to start out with count equals 0, and then do something like while count is less than the length of turtle data. Then do this and say count equals count plus 1. But there is a way, instead of using a while statement, we could use a for statement that would make it so we don't have to keep track of the number.
What about turtle ID?
Well, we're eventually going to do that, Elvis, but right now we're just doing this for turtle 1. But eventually we're going to do it, we're going to have 2 loops. Okay, but you're getting ahead of yourself. We're going to have to loop through all of the turtles eventually. Yes. Yeah, but right now we're just looping through all the turtle locations for one turtle.
Okay.
So remember, turtle data, what is it? What data type is turtle data? A list. How do we loop through every element of a list?
Okay, so,
Just in general. If I want to make a loop that loops through every element of a list, how do I do that?
Let's say for something in the list.
Yes, for something in the list. So what would I do here?
For turtle and turtle list?
Yeah, for turtle in turtle data, right? Now, so I'm going to get rid of this. Yeah, so I might call these turtle locations. Or maybe not pluralize it. So what this is doing is saying for each turtle location in turtle data. So the turtle data gives us a list of all the places that turtle's been. And so this loop is going to say for every turtle location in that turtle's data, do this. So now we need to find the X and the Y data for that. So what this loop has done is the first time through, what's turtle location going to be equal to?
the first time we do this,
Yes. So it's going to be equal to turtle location, exactly. Turtle location will be equal to turtle data 0. Next time through the loop, it's turtle data 1. So it's doing that for us. So now turtle location is equal to this dictionary right here. Okay. The next time through the loop, it's going to be equal to this dictionary. Sorry. This diction. I'm highlighting two dictionaries. That dictionary. Okay. So in this dictionary, how do I get the X location? Can you speak up a little bit, Elvis?
Count to change the number of the order of events. Keep changing the number based on count, right?
Well, it's like the third dictionary.
Right, but do we reference dictionaries by numbers?
No, you need the key.
Right. So what is the key that I need that is the X? So this is the key, this is a value. This is a key, this is a value. This is a key, this is a value, and so on.
So the ladder belongs.
Right. So which one represents the X?
So X equals turtle data later.
It's remember turtle location is equal to the turtle data, the individual element of the turtle data now.
Right.
So it's
Location and then lab.
it actually is long, but that's fine. I mean, you probably said lag because it's the first one. I make that mistake sometimes, all the time. All right.
Is it LNG or LF?
It's whatever it is over here. You see it? It's that.
Okay, I couldn't see it. It's a little small. I was trying to make
Yeah. Okay. So, and then this would be turtle location. Yeah. Lat. So now our point is going to be the latitude and longitude of that turtle location at that time. And then it's just going to keep building that location over and over and over again. Okay. So, oh, sorry. You're right. Lat. So now this should be ready to run. Name turtle data is not defined. Turtle data right there. Did I spell it? Oh, I remember it's case sensitive. So turtle data shouldn't be capitalized, or else it should be capitalized up here.
This was initialized, right?
Well, yes, I created turtle data right there. Created turtle data right there. So here I can. I deleted the print statement because it's no longer necessary. That was just for amusement. I'm going to put all my import statements at the top just to get them together. I think that's, and even the environment part. Okay. All right. I think that'll be good. Now I'm going to try to run this again. So the error was turtle data is not defined. And so I had to look and I said, well, I defined turtle data up here. Oh, but I spelled it differently. So now it ran. So now let's look in ArcPy. I can go add the data. I called it turtle tracks. So I need to refresh to see if turtle tracks is there. There's my turtle tracks. Zoom out. All right. There's turtle 1. There's where it went. So it started up here. Actually, I don't know where it started and where it ended. But
the outpath, so like the placement, that's where you're when you buy the output, right? Usually the outpath.
yep. So that's where it put it. That makes sense.
Mm-hmm.
Okay. So now what I've done is I created the turtle track for one turtle. What happens if I wanted to do this for turtle number 244? How could I change my code? Right, 244. I'm going to have to, I could call this turtle tracks underscore 244.
Could you do that model bill and do an iteration and run it off each
Well, okay, so I couldn't do everything I've done here. I could not do in Model Builder because Model Builder doesn't let me create a geometry and write a geometry out.
Oh,
But I could take this code and make a model so that it requests the turtle ID number and then outputs a shapefile that shows you that turtle's ID. It's exactly right. Yeah.
Did you map the 244? Is that 244 that you just mapped?
No, this was the first one that I did, but I'm going to go ahead and run 244 right now. Now I'm going to add the data, and I should have turtle. I wonder, I'm going to delete it so that it actually gets rid of it.
244 is done by me.
Oh, I called the turtle tracks 244. Yeah, so that I got off track. I called it turtle tracks 244 so that it would actually wouldn't overwrite it. There we go. So there's turtle track 244. So basically they picked it up and it moved up or down. I don't know which direction it's going. Up the Miami coast. So that's where they picked it up and dropped it off. See that? So I changed to 244 there so that it would. So I can get any turtle from that. So let's look at turtle ID 2. The ones that are earlier in the database are going to have more data, more data points. I mean, not necessarily true because some of them will have lost their data points really early. That is exactly what the assignment is. Okay. So here is turtle 2. See all the places it went? Okay. Yeah, it went, it even went, it went out of the country. It was in Florida and then it went to the Bahamas. What's that? Yeah, went on vacation. Well, the other one did too. That other one went Mexico all the way down to Costa Rica. Yeah, it's avoiding the Bermuda Triangle. Okay, so yeah, that's the assignment, Elvis and everybody else, is that you need to modify this code so that it doesn't just insert a single row, it inserts multiple rows. So you're still only going to have one insert row statement, but it's going to be part of a loop. You're going to have to build a loop around it, and you're actually going to have to rearrange some of the code. Okay. So I'll go ahead and save this, but this code right here, how many times does that have to run? Creating the shapefile, because what you actually want is one shapefile with a bunch of records. So you only need to run this part once. So we should probably move that up out of the loop. But does this need to be part of the loop? That is part of the loop because turtle ID needs to change.
Right.
Turtle ID is what needs to change each time. So you need to write a loop that'll make turtle ID 1, that'll make turtle ID 2, that'll make turtle ID 3, and so on. You could do it with the counter. That's one way to do it. There is also a way to write a for statement because there's the function range that returns a list. Here, I'll show you what I mean there. So that's what I would. So this will still run. Let's do 3 for fun. You're not actually going to run this. You're just going to have this run so that this is turtle tracks. See what I'm saying? Okay. So that ran. What does 3 look like? Add data. So there's turtle 3. Whoa, that one really got around. So it looks like that one doesn't have any other, well, no, it has this land. No, that's not land. So it probably started here in near Panama, right there. Kind of went around there and then went up there, went all the way around and went to a bunch of crazy places.
Is there a way to identify on app what's the starting point?
By Louisiana, scroll back to right.
By Louisiana? So it got pretty close to us.
Yeah, I was like, wait. It's by Louisiana, not too far from this.
Yeah, there is. So you can take the symbol and change the symbol so that it is. There's a way to put an arrowhead on the symbol. Caps. Nope, that's not it. Cap type. No. I know there was a way. I'm sure there's a way, because there was a way in ArcMap. Let's see here. ArcGIS Pro. Add arrow to line. Show direction of a route with an arrow symbol. Click the line symbol. Symbology pane. Search for arrow. I guess under gallery, type arrow. Extend at end. So there'll be a line. There'll be a cap at the end to show. Okay, what does this one say? Yeah, arrow directional. So, which one was that? This one? So that's the very end line. That's the last line. That's where it ended. And this is where it started. Right there. There should be a way to do that. This just says middle. Arrow at end. Extended end. Yeah, there should be a way to do that. That one's start and end, right middle. That just says in the middle of it. I don't see one that does that, but there's got to be a way to do that. All right, so let me just demo real quick. If I said for x in range 1, 244, print x. Oops. For x in range 1, 24. I should actually go to 245 and say print x. Whoops. See, it'll do what we want to do. 1 all the way through to 244. So that's what you want to do, is you want to incorporate something like that. You could do it with a while statement. You could say while x is less than 245, and then you could just do x equals x plus 1. Or a better way to do it is while turtle ID is less than 245. See what I'm saying? So yeah, everything below here is in a loop. Another hint there. Don't put this in the loop. Okay.
Don't put it in the loop.
Right. You're going to need an if statement right here to skip all of this part. Like you don't want to do any of this if the turtle data is empty. Okay? All right, so also, to get full credit, you need to save the turtle ID into the ID field. So you'll need to modify the insert cursor here. You'll need to not just get the shape, you'll need to get the other field that has the ID field in it. And then when you go to insert row, so what I'm talking about here is, look, when I open the attribute table here, see how there's an ID and it's 0? That ID needs to be the ID of the turtle. Okay. So what's the ID of the turtle? That in this case it should be 3. So you need to go and look at the examples if you don't understand how to do that, or find some other way to do that. But basically, right now you're only getting the shape field, and you need to make it so that you get more than just the shape field. You need to get the ID field too. Okay, and we did that. Several examples of getting additional fields. The field's not called turtle ID, it's just called ID. Big I, little d. So you'll need to make that work. So basically, this line will change. Instead of giving it, right now you're giving it a list, but there's only one thing in the list, and you'll need to give it two things in the list, but you'll also need to give it two things in this list. And they're not going to be the same thing. Okay. Think about what you're going to give it. Like, I could just manually give it 3 right here. Whoops. Comma 3. And that would give it 3, but I also need to tell it that that's going to be the ID somehow up there. And you need to make it so that it's not 3 every time. It's always the value of turtle ID. Because turtle ID is going to be changing every time through the loop. Okay.
So it should be a number by turtle ID.
I'm sorry?
It should be a number by turtle ID. It should initialize at 0 and let you know this.
However you want to write the loop, you can do it by initializing a variable, or you could just use the for statement that I gave you already. But you're going to loop through. You're going to loop, like the first time through the loop, turtle ID needs to equal 1. The next time through the loop, turtle ID needs to equal 2. And the next time through, 3. I'm going to change this because we need it to just be called turtle tracks. So the only thing in this loop that needs to change is that this number needs to change a bunch of times through the loop. And then you need to check if it's empty and not do this part. And then you also need to make sure that you save the turtle ID into the number.
So for that part, could you do turtle ID equals turtle ID plus 1 each time?
Yes, you could definitely do that. That's what I'm saying. So you could go down here and say, you can initialize it and say turtle ID is equal to 0, and then at the bottom you could say turtle. I wouldn't say 0. I'd actually start with 1. But you could go turtle ID. I got to spell it the same. Turtle ID is equal to turtle ID plus 1. You could do that. And then you would write a while statement and say while turtle ID is less than, you'd write a while statement right here, and then you'd indent all this code and write a while statement that said while turtle ID is less than 1. So that's one way to write the loop. And I think it's a fine way to write the loop. You could also put a for statement in that would be something like for turtle ID in range 1, 245. And then indent all this stuff, and it would have the exact same effect. Okay, both of those are equivalent statements. One's using a while loop, one's using a for loop, but they're still going to have the effect of creating turtle ID 1, turtle ID 2 next time, turtle ID 3 next time, and so on. See what I'm saying?
Well, the parentheses on cursor insert row, my space font.
I messed that up. Thanks. All right. So I commented that up with everything that you have to do. And then finally, the last thing that you have to do there is to just making sure it's recording. To get full credit is you have to create, your script has to create another shape or another layer. It could be a shapefile or a geodatabase that so let's look at that is the convex hull. Now, I'm not going to ask you to do the convex hull the way you want it to, unless you want to, unless we did it. If you want to do it the way we did it in class, that's fine. but there's a tool that will run the convex hull on all of the data. And so you'll run minimum bounding geometry on that. So basically, look, if I go here and I do geoprocessing, minimum bounding geometry, and I run it on my turtle tracks here on turtle tracks 3, I'm going to choose convex hull and run it, and it's going to give me the convex hull there. That's the convex hull for turtle track 3. See that? So just run that at the end. So I'll even go ahead and comment that in. Now run. I'm just going to copy the exact name of the tool. On the data set to get a new data set that is the convex hull of all the turtle tracts. There we go. Then that's it. That's all you have to do to get it in full credit.
Do we have to write that into our code, the minimum bounding geometry?
Yes. Yeah, that has to be in your code. So you have to call it.
So from our map, if we absolutely have to.
What's that?
So we can export our code if we absolutely had to.
Yeah, I mean, you could. It's only.
Or you get it from those examples you created earlier, right?
Yeah, but that would be more complicated. I think the easiest way to do it is just to copy this over into the code and fill in the right. So what's the in features going to be? The turtle tracks. Yep. And the out feature class is going to be whatever you want it to be, and then it'll run. So you have to change those. You want me to leave that line in there or take it out?
Yes.
Okay. But you'll have to change these two values to get it to run right. All right. Now, just for fun, since you guys asked me to show you about creating a toolbox, I'm going to save this as, I'm going to save this as turtle track tool.py. Okay, and then I'm going to delete this part. And I'm going to yeah. Okay. Out path, out name. So I want the user to be able to specify where they want to save their turtle track. So I'm going to this isn't gonna be a loop. Remember I saved this over the other one. Not over. Let's see. Let's make sure I can still open the other one. Yep. Okay. So that's all still there. So the one that's actually the assignment is still there. So this part of the assignment is me showing you how to create a tool. Okay. Which is very similar to the way that you would do it for the assignment for the test that some of you have to redo. So what I can do or can redo. Okay. So what I'm going to do is these comments don't really apply anymore. Just like that. That way this will be a little bit smaller. And this is all the information that I need to gather from the user. I need the turtle ID, and that's going to be a parameter. So also, I'm going to do this because we don't need to worry about that anymore. Usually you don't want any environment variables in a script that's going to be a tool, because the user can set the environment variables, and you don't want to, like, basically you're stepping on the user's toes if you set an environment variable. What you're doing is you're saying, oh, I want to be able to write override output no matter what. But the user can do that. So usually take out environment setting things in a script that's going to be a script tool. So right now, because I don't know how to spell anything, I'm going to say arc py.get parameters from as text, because I don't know how to spell. Okay. So here's my example. And this is going to be the first one. So I'm going to say arcpy.get parameters text 0. That's going to be the turtle ID. The other thing is the output location. Now that is actually going to be the output location 1. That's going to be the output location that they specify. In other words, where do you want to store this turtle track on disk? Okay. Well, I don't know where they want to store it on disk. I'm going to be asking them for that. Okay. All right. So let's go set up our tool now so that we can see what that looks like. So go in here, and I'm going to go into my toolboxes, and I'm going to create a new tool, a new script tool called, I'm just going to call this generate turtle track. I'll give it that name and that label. And the script file I'm going to use is this script file, so I need to save it. So the turtle track tool script, that's under C temp. No, it's under C users George courses SPA M7. This is turtle track tool. Okay. Now the parameters, what's the first parameter that I need to get? Yeah, so I need the user to supply the turtle ID. And what data type do I want to give it?
Long.
Yep, long. I'm going to show you something that you can do. You could say that you want to filter, and you could say range, and you could put in 1, 244. We didn't really cover this. But what that does is it only allows the user to input a value between 1 and 244. Now, in reality, I might not want to do that, because eventually, they just tagged a new turtle 3 days ago. They're going to tag a new turtle eventually, and then I won't be able to get that turtle if I put in 244. But for now, I'm just doing this as an example. Now they can only enter in 1 to 244. Okay. All right. Now, what other information do they need to provide?
Feature class.
Yeah, the feature class, the output turtle track, and I'm going to call that. I'm going to make that what?
Feature class.
Exactly. That's going to be a feature class. Okay. It means it can be a shapefile or anything. Now, what about any of these other values? Do I need to change any other values? Their direction needs to be output. If I don't change the direction to output, they're only going to be allowed to input feature classes that actually exist. And this is a feature class that we're creating. All right, so I want to do the output. Okay. All right, now if I say OK here, what's going to happen when this runs is that the output location is going to be the full path to where they want to save it.
I think we changed to 0 now, though.
No, turtle ID is 1.
Oh, okay.
Yeah, turtle ID is 1, and turtle track is the next one.
Yeah, I just saw a little bit of glare on the sign.
Now look at this full path here. That's fine, except for the fact that the out path and the output name, we need those separate now. You see that? We need for create feature class. It's a tool where we need those as separate things. We need those as separate entities. So that's a problem because they're together. So we need a way to break them apart. So we need to find the path and the name. Okay, right now we have the full path, and we need to break it apart into path and name. There actually there's a built-in Python tool for that. Python get file name from path. Yeah. All right. So it looks like well, it looks like what they're arguing here is that in cases where you don't have Windows, or you do have Windows, it'll have a problem. But let's see. Okay, so it says that this will work in all cases except for where if you have a slash at the end. Will work for all paths on all platforms. Of course, if the file ends with a slash, the base name will be empty. That's not a problem for us. So ArcGIS is never going to let them put a slash at the end. So we know that will work. So let's just see how this works real quick in here. So I'm gonna open up a Python window. Where's the Python window? Map, analysis, there it is. Python. Okay, so I'm gonna say yeah, path equals so that's going to give us the base name, in other words, the file name. I wonder how we get the other part. Now the path here would be A/B, and the file name is C. So let's figure out how to get that. So here's the end path model. It's the dir name. So let's make sure that works. Print n. Oh, yeah.